Students, this is another nomenclature question. This time they're giving you the name and asking you to write the formulas. It's usually easier to go this direction than to go the other direction. Once again, you definitely have to know your naming rules, and you have to know your polyatomic ions to do this one. Let's first distinguish between ionic and covalent. And once again, the way we would know that is if all the elements in the compound are nonmetals, then you have a covalent compound. If you have a metal or ammonium ion, then you have an ionic compound in it. So, and I think everybody's would be the same since there are no red elements, or nothing's written in red for this. So sulfur difluoride. Oh, and the other giveaway, if in the name they have prefixes, then it's definitely a covalent compound, binary covalent. So sulfur difluoride, covalent. Sulfur hexafluoride, covalent. And everything else is going to be ionic. Sodium is a metal, lithium is a metal, chromium is a metal, tin is a metal. Ammonium ion, substance G is ammonium acetate. The ammonium ion, even though it consists of nonmetal elements, it still acts as an ion. So that's ionic. Same thing with ammonium hydrogen sulfate, cobalt nitrate. Cobalt is a metal. Mercury is a metal. Potassium is a metal. Sodium is a metal. So every single thing after the first two are ionic and follow the ionic naming rules. But the first two are covalent, and it's actually pretty easy to write the formula. If it's sulfur difluoride, there's only one S, and the di means that there's two fluorines, so SF2. Sulfur hexafluoride, hexa means 6, SF6. Now for the others, if they tell you sodium dihydrogen phosphate, that used to be called bisphosphate. Dihydrogen phosphate is H2PO4 with a minus, and sodium ion is a +1. So when you go to crisscross these charges, the charges are 1 and 1, so it just becomes NaH2PO4. Lithium nitride. Lithium ion is +1. It's in the first column of the periodic table. Nitride ion is in group 5 or 15. When you go to crisscross these charges, each ion will take on the opposite ion's charge as a subscript. So it becomes Li3 N. You need 3 lithiums in order to cancel out the charge of one nitrogen ion. That's what those subscripts tell you. Chromium carbonate. Chromium, they tell us with the Roman numeral that there's a 3+ charge. We needed to know that information, otherwise we couldn't write this compound. And carbonate is a CO3 with a 2- charge. When you go to crisscross, you'll need to put the carbonate ion in the whole unit goes into a parentheses. So it becomes Cr2, CO2, CO3, 3. Tin fluoride, they tell us, tin 2 fluoride, they tell us the size of the charge from the Roman numeral. Those should match. So the Roman numeral 2 matches the size of the charge 2+. And then fluoride is in the 1- column, group 7A or 17. When you go to crisscross these charges, it becomes SnF2. Next one, ammonium acetate. NH4 plus, and acetate ion is C2H3O2 with a 1- charge. It's a lot of letters to write, but they both of those polyatomic ions take a 1 subscript, so it just becomes NH4C2H3O2. Next one, cobalt-3 nitrate, ammonium hydrogen sulfate. Hydrogen sulfate used to be called bisulfate. It's HSO4, HSO4 with a 1- charge. And ammonium is NH4 with a plus charge. And we'll just crisscross. And you get NH4 HSO4. No parentheses needed. If the number that you would have put outside the parentheses is a 1, then you don't need the parentheses at all. Cobalt-3 nitrate. Conveniently, they tell us that the cobalt will have a 3+ charge. We know that from the Roman numeral, cobalt-3. And then nitrate is NO3 with a 1- charge. When you go to crisscross these the elements, you get CO. Here you do need a set of parentheses, NO3, and then the 3 that came originally from cobalt's charge becomes the subscript for nitrate. Mercury 1 chloride is the next one. Mercury 1 is an interesting polyatomic ion. The reason they specify it is because normally mercury would be a Hg2 with a 2+ charge, but in this case it's mercury 1, so it's just Hg with a +1 charge. And then chloride is a 1- because it's in column 7A or 17, same column as fluorine is found. So HgCl. And then the next one is potassium chlorate. Potassium is just K+. Chlorate ion is a ClO3 with a 1-. When you go to crisscross those charges, you get K1, which you don't need to write as a subscript, and then a ClO3. If it were in parentheses, you would have a 1 outside it, but you don't need to write that. So KClO3. And then our very last one is sodium hydride. Hydride ion is, okay, we should talk a little bit about hydride. Hydride is not, hydrogen normally would take a +1 charge, and that's just the hydrogen ion. But if they ever say hydride, it means hydrogen with a -1 charge. So this one is just NaH.